So guys, as you can see, we have these LEDs pins connected to the port B here, and we have this button at the back. Now we will only use one command to trigger the complete port. See, the complete port turns on once I press the button. Complete port B goes high. Now it's by default low. By default the port B is low, but once I press this button, it turns all the pins of the port B high, but we only have 4 LEDs connected. See, it is working like a charm. Let me show you the code as well. So in the code here, let me zoom in. You can see that we just triggered the complete port B as output using this command, and then we initially made all the LEDs go 0. That's why they are off when no button is pressed. Then we initialize the button, and then we did is that we check if the button is pressed. If it is pressed for more than 50 milliseconds, then consider it pressed, and then turn on all the pins of the port B goes high. All the LEDs connected to port B will be on. Now else if nothing is pressed, then they are 0. Simple as that. So this programming gives us this result over here. See. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how we can blink 4 LEDs connected to a PIC16F877A on and off using MikroC for PIC programming tool. So guys, what we are going to do here is that I will be toggling a complete port, unlike a single pin that I did in my previous video on blinking an LED. This time I'm gonna blink the whole port. Like I will be using port B, and I'm gonna blink all the 8 LEDs of port B using a single command. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. So guys, this over here is our first LED. This is the second, third and fourth LED. So I will be using only 4 LEDs to demonstrate the 8 pins of a port. Like we will be using only one command for the port B that will toggle all the LEDs on and off. Now guys, this over here is our 4 LEDs. Now the next thing is, we got our 4 LEDs. Now let's do the connections. As you can see, each LED has 2 pins, one longer and one shorter. The longer pin is the power, the shorter is always the ground. So for the ground pins, this and this, just common them and send them to the common ground of your PIC16F877A microcontroller like this. Now the longer pin is the power pin, but you will not connect the longer pin directly with your PIC. You will use a safety resistor. I will use 4 safety resistors for 4 LEDs, one for each LED. Now guys, this safety resistor value, that depends upon you. Like it can be from 100 to any higher value you want, but higher the value of the resistor, the dimmer the LED will go. So I will use a 220 ohm resistor that will also save the LED from getting burned, and it will also ensure that we get enough brightness of the LED as required. Now guys, for the longer pin of the top LED, connected to the one end of the 220 ohm resistor like this. From the other end, connected to any available digital input output pin. In my case, I'm going to toggle the port B, so I connect it to the pin number B3 like this. Now for the second pin, second LED, do the same. Connect the longer pin to the one end of the 220 ohm resistor. From the other end, you can connect it to any available GPIO pin. I'm going to use the pin number B2 like this. Now for the third LED from top, do the same. Connect the longer pin to the one end of the 220 ohm resistor. From the other end, you can connect it to any available digital input output pin. I'm going to use the pin number B1 like this. Now for the fourth LED from top, the longer pin connected to any available connected to the one end of the 220 ohm resistor like this. From the other end, you can connect it to any available digital input output pin. I'm going to use a pin number B0 like this. Now guys, this over here is our push button. It have only 2 pins. I name one as signal, other as VCC like this. Now guys, for the VCC pin, you connect it directly to the VCC pin. Okay, before we connect the VCC pin, first of all, we will need a resistor, either a pull up or a pull down resistor. So this 10K resistor can be configured in a way that whenever the push button is pressed, a 1 will be sent. Or we can also connect it in a way that whenever the push button is pressed, a 0 must be sent. So in my case, I'm going to connect it in such a way that whenever the push button is pressed, a 1 is sent. Now for that, first of all, the VCC pin, remember that this signal and VCC pin, this push button is a non-polar component. Unlike the LED, you can shuffle these 2 pins. It doesn't matter. Like you can make the signal the right pin, VCC the left pin. It will not matter. So first of all, I connect the VCC pin to the VCC pin of the PIC like this. For the signal pin, connected to the one end of the 10K resistor like this. From the other end of this 10K resistor, you connect it to the ground like this. Now guys, from the same signal pin that is connected to the one end of the 10K resistor, from the same pin you will take out your output. For the output, you can use any available digital input output pin. I'm going to use the pin number D1 like this. Now guys, take a look here. This 10K resistor's one end is connected to the ground. This means that whenever this push button will be pressed, a 1 will be sent. Now in case this 10K resistor's one end was connected to the power like VCC, in that case whenever the push button is pressed, a 0 will be sent. In this way our connections are completed. Now let me introduce you to the hardware before we move on to the programming. So guys, hardware is here and it is very simple. These are the LEDs, as you can see. There at the back is our push button we are going to use, and you can see that these LEDs are connected to the port B. So this is simple, very simple hardware configuration. Rest is just a trainer board. And I will also share the link to the video in the description in which I told you how you can set up your hardware for first run. Now guys, let's go to the MikroC for PIC to start programming. This is our MikroC for PIC. Let me zoom in so you guys can see better. So guys, as you can see, this is version 7.6.0. So you can use any higher version as well. I will also share the link to the video in which I had shown you how to download and install this MikroC for PIC for free from the official website, full version. So let's get started. Click on File, New Project. This window pops up, New Project Visit. Click on Next. Write the name of the project. I write here, okay, port based LED blinking tutorial by Learning Microcontroller. So this is the name I wrote. You can write any name you prefer. This is the path where the files will be created. Select the microcontroller. I'm going to use a PIC16F877A. Write the crystal whichever you are using. In my case, the crystal connected to the pin number 13 and 14 of PIC16F877A is 20 megahertz. So I will write 20 here. Click on Next and Finish. Now guys, before you do anything else, first of all save your work. Press Ctrl S. Now guys, first of all we declare the pins. Write down TRISB equals to 0 cross 0 0. Now why this command? Unlike the previous videos, we used to write TRISB.F0 means the port B pin number 0. But now we are toggling the complete pin as output. Now this TRIS register will make sure that complete port B is output. It has declared complete port B as output. Now initially we want all the LEDs to be off. We do the same. Port B equals to 0 cross 0 0. This means every pin of the port B now gets a 0. So this command makes sure that all pins of port B are 0 by default. Okay, this is the initial state. Initially all the LEDs are off. Now guys, we initialize the button. Button is connected to pin D1. TRIS D.F1 is the button pin. Dot F1 equals to 1. Now see, for the button pin I just send 1 because we are just triggering a pin, not a whole port. If it was complete port, I was to write 0 cross FF, the complete port triggered input. But in my case only one pin, one button is connected, so I write TRIS D.F1 equals to 1. Now guys, initially as I told you, our button sends 1 whenever it is pressed. So initially by default it must be 0. So port D.F1 equals to 0 by default. So whenever the code starts, this don't gets triggered. Now we move to the forever loop. Starting from here, while one forever loop starts here and ends here. And inside it, what we do is that we check if the button is pressed. If port D.F1 double equals to 1, it means if the button is pressed. Now see, that 10 kilo ohm resistor made sure that a 1 is sent whenever the button is pressed. So in case we don't know what that resistor means, then we will not know what is to be sent. We have to check by DMM or something. So if 1 is sent by the if 1 is received by the button pin, then it should enter this loop and again check. Now again we check, and now we have a double check here. Now first of all we check if the button is pressed, and we add a delay here, delay MS 50. Like if the button is pressed and it is being pressed for more than 50 milliseconds, only then go into this loop. If you don't add, this is called debouncing delay. I called it debounce delay. This happens because this is required, because if you don't use debounce delay, then there is a possibility that button may get triggered by some unknown phenomena like static shock or some dust particle in the air, and your loop will get triggered, and that is very dangerous, especially when you are dealing with machines. So you make sure that you always give the debounce delay. This makes sure that if the button is pressed for long enough that it is being pressed by a human hand, it will be at least like 8 milliseconds. So I have given 50 millisecond delay here. So if the button is pressed and wait for 50 milliseconds. If it is still pressed, only then turn on the complete port B. Initially port B is off, all pins are 0. Now complete port B has been turned on. Now turn it on. Now else. Now we write the else loop. Else, go back to the initial state. If nothing is pressed, it means that we should be back in this state, that is our initial state, that complete port B is low, off. All the LEDs of the port B are off. Now this is the code we wrote here. What we expect from this code here, whenever the button is pressed, all the LEDs of the port B will turn on. So we have 4 LEDs connected to it, so all 4 LEDs will turn on. So we build the code, no errors, like this. Now go to your PIC16 programmer tool, this tool. I will also share the link to the video in which I have shown how you can download and install this tool for free. So go to import hex file. This is the file we just created. Double click on it. I think this is the file. Okay, that is the file. Click on write. Okay, this file is being written. So let's get to the hardware before it's done. Okay, we are at the hardware and the file is being written. I will power up the circuit using the PIC16 programmer tool. So it's on. See, circuit already powered up. See, it's on. Now guys, the good thing is our code is working fine, because see, by default LEDs are off. That's what we just did in the programming. We turned the pins low by default. Now once I press this button, the LEDs must turn on. See, they are on. So once I press this button for more than 50 milliseconds, it turns on the LEDs, else they are off. See, the code is working fine. See, so that's how you can just trigger complete ports using a single command instead of giving commands to each pin one by one. So this is another technique of doing this. So guys, this is it. If you guys have any questions, you can ask me in the comment section. The code of this video, the programming I did, will be in the description of the video. You can just copy paste the code and play with it. So guys, we'll see you in the next video. Thank you very much guys. Have a nice day.